Okay, in this video we're going to look at some of the formulae for standard deviation. So standard deviation is a measurement of spread. It's a measurement on how the data is spread out. It's similar. It could be like compared with the semi-interquartile range, which is also another measurement of the spread. Now, how is the standard deviation worked out? The standard deviation, Sn, is the sum of taking each piece of data x and seeing how far it is away from the mean. Now, because some of these will be positive and some of these will be negative, you get a more meaningful result if you square each of those differences. So just repeat, it's how each piece of data is spread from the mean. And then what you do, you square that, and then you take the average, and because you squared, you should take the square root. Now the mean is obviously you add all the bits of data up and divide by the number of items. Note that if you were to square this, you get what's known as the variance. And one of the problems with this formula that it's not very easy to use. So the formula is not very easy to deal with, so we'll consider, let's just for the moment just consider the variance. Sn squared is the sum of x minus x bar all squared over n, and what we know from our algebra, we can expand that. So let's just call the n, let's take the 1 out of n out. So if we do square that, we get sigma x squared minus 2 times sigma x x bar plus sigma x bar all squared. Now, because we're just summing x's, we can take that x out. So we get sigma x squared, 2 times x bar times sigma x. And because you have to sum up the mean n times, you can now say that now that's n x bar squared. So we have to sum up the mean squared n times. There are n of those, so we do n times that, which replaces that. Writing that line out again. If we now take that n in, we get sigma x squared over n minus 2x bar sigma x over n plus x bar. That's x bar because the n's will cancel. Right, we know that sigma x over n is equal to the mean, so we'll replace that with a mean, so we're going to get sigma x squared minus 2 times the mean squared, x bar times x bar, plus the mean squared, which is sigma x squared over n minus x bar squared. However, if calculating from a sample, we don't really know what the standard deviation is. We have to use a good estimator. And what we use is what's known as the unbiased estimate for the variance, or the standard deviation if we take the square root. So the relationship between the two is that the unbiased estimate, which is this thing here, is n over n minus 1 times the standard deviation, or the square of the variance squared, which is what this is here. So carrying on, we get the unbiased estimate will be n over n minus 1 times this, sigma x squared over n minus x bar squared. Just writing that out again. If we take that n in, it's going to cancel with that, and we're going to get an n up here. So we're going to get sigma x squared minus n x bar squared divided by n minus 1. Now this bit here is called sxx. So this now becomes sxx over n minus 1, and if we want the standard deviation, it's Sn minus 1 taking the square root of Sx over n minus 1. So this is what you will see in your textbook, where Sxx is sigma x squared minus nx bar squared. Now on your calculator, on your TI calculator, you will see that Sn1 is represented by Sx, and the Sn is represented by sigma x. This is sigma x, a small sigma. So this is what it's represented. It's in this order on the calculator. Sx and sigma x. It's in the same order here. Okay, so you need to know which one to use. Now, in your A-level course, you are expected to use this one here, and this formula here. Okay, and then if you have a frequency distribution, then this will now become the same. This is exactly the same, but Sxx will be sigma fx squared minus nx bar squared. So this has been a video to show you about the different formulae used for the standard deviation. So the main one you need to remember is this one here. I hope you've understood. Thank you very much for watching.